are 10 easy science fair experiments that you can do in your backyard or local park. All of these are low cost and accessible to most grade levels, and I'll be talking about ways to bump down or level up the difficulty for all of these experiments, depending on what level of science experiment that you want to perform. You may need to purchase a few materials for some of these, but most of them are pretty low cost and are under $10. Let's start with number 1. Tree coverage versus temperature. Remember, a good science experiment should have an independent variable, something you change or study under different conditions, and a dependent variable, something you observe or measure. So in this experiment, the tree coverage is our independent variable and temperature is our dependent variable. It's the data that we're collecting. Remember, D for data. So it's well known that trees can significantly cool the area of a surrounding environment. So you want to investigate by how much. So you can explore the relationship between tree canopy or the amount of leaves around and temperature by measuring temperatures in areas with or without trees, or comparing areas with different amounts of tree canopy. Or you can make it really simple and measure the temperature in the areas with shade and direct sunlight. You can also do more of a gradient and investigate how much tree canopy you need to have a significant cooling effect. Or you could do it over a long period of time and see when that cooling effect is most pronounced. Is the tree canopy helping most at nighttime, daytime, both? Backyard science fair experiment number 2, location versus ambient noise. For this one, you want to download an app to measure the decibel levels, which there are plenty out there that do this. I downloaded this one last year when we had a big cicada brood emerging because I wanted to hear how loud the cicadas were getting in my area. You can check out the noise level in different locations around your yard or your neighborhood, or you could take it a step further and look up data to correlate population density or traffic with ambient noise levels. Or if you want to keep it more nature focused, you can measure the ambient noise during different times of day, different seasons even, if you have a long period of time to do this experiment. If you want to get into citizen science programs and not just do ambient noise, you can even record bird sounds in your area and log them on a site like this. Experiment number 3, you could do some biodiversity sampling. So this would be another one where the independent variable could be location or shade or some other factor, distance from the road. But a quadrat sampling is a type of sampling that ecologists use to look at different species in an area. It's usually a square frame around 1 meter squared, throwing down this frame and you're sampling within that area and then going to a different location. But this makes sure that the samples you get are of consistent size and shape. And number 4, pillbugs and their behavior. This is a really good one to do as the temperatures warm up and you can find pillbugs or isopods in your backyard. I call them roly-polies, you may call them something else, but it's a really fun one to do in the warmer months. Collect your pillbugs and then create a choice chamber out of petri dishes or Tupperware and put one condition on one side of the chamber, another control condition on the other side, and then record how many pillbugs are in each side of the chamber every minute for 10 minutes. You can do this with tons of different variables. You can do a moist versus a dry environment. You could do it sugar versus nothing, light versus dark. The independent variables are limitless here, and you can do this with however many pillbugs or for however long you want. Experiment number 5, creek water monitoring. Now you do need a water source for this one, but here you're going to be using macroinvertebrates to assess the quality of water at a local creek or pond. To do macroinvertebrate sampling, you're going to create a leaf bag and set it up, leave it out for a period of time, come back and then collect your samples. Here you're looking for macroinvertebrates that are either pollution tolerant, meaning that they could exist when there's a lower water quality, or more pollution sensitive, and these are going to appear when the water quality is good or there is less pollution in the water. For 6, you get a bunch of UV beads and you get ready to experiment with sunlight and UV exposure. UV beads are fun just because they turn colors in the sun. Look how fast these turn when I go from a shaded area to a sunlit area. But you can do any number of experiments outside with these, from timing how long they take to turn a different color in different locations, or you can lather them in sunscreen and see the effects of a certain SPF on the rate of color change for the beads. These are super fun to play with, and there's a ton of different independent variables that you could work with, and they are relatively cheap. I got a giant bag of them to play with myself. Number 7, you can do some invasive species investigation. So your experiment can be related to different methods of controlling invasive species, from kudzu to Hedera helix, English ivy, or any other invasive species that you find in your park or backyard. Make sure you have permission from whoever owns the property to do this, but you could experiment with different control measures like pulling plants versus using herbicides, or even putting up a protective barrier to prevent these invasive species from growing. This one could take a little bit more time because you'd have to assess how the invasive species are growing over time, or it could just be an observational experiment where you record how much coverage invasive species are taking over in a particular area. Number 8, a flower dissection. Now, this is an easy one to do without using the scientific method. There's plenty of different flowers you could get from the store or from a natural area, but your independent variable here could be flower type versus number of sepals, or flower type versus the presence or absence of certain reproductive structures. Think about a way that you could pick an independent variable here and then find something to measure along with your flower dissection. Maybe you're going to look at petal size versus pistil length, or if it's springtime, you can do a pollinator count experiment. It's really up to you. Number 9, this is a fun one, an oldie but a goodie. You're going to be doing some sampling with moss in trees. So can you use the presence of moss to determine direction? This is relatively low cost, but the more samples you get, the better your data will be here. And you want to determine out of all of your samples how much moss is growing in which particular quadrant, north, south, east, or west, as you collect your data. All right, and number 10, you can investigate the pH of rainwater or a local creek or puddles around your neighborhood or backyard. This, again, the independent variable could be location, or whether or not a storm has happened, or water source, runoff, anything that you want to pick. And then you're going to sample the pH using pH paper, or if you have a fancy pH meter, you can do this as well. pH paper is relatively low cost. You can order it online and then use the indicator paper to find the pH of your different samples that you collect, whether that's pond water, creek water, water from your drain. There's a lot of different opportunities to measure here. Maybe you want to sample the pH of rainwater throughout different times of year, or in areas where there's a lot of cars versus fewer cars. The great thing about science fair experiments is that there are a ton of variations on them. Thanks so much for watching. Give this video a like if it's been helpful, and I'll see you later.